We can't hear.
Yeah,
Okay.
Thank you, Dr. Fatmana, for reading out the loud profile. I hope I am audible now. Yeah, so starting with my presentation for today, let me share my screen.
Okay.
Yes, I hope it is in the slide share mode and they are moving. Yeah.
Yes, yes, we can.
Yes, it's visible.
Thank you so much. Thank you all the organizers for giving me this opportunity to speak at this platform. And I'll be speaking about semantic intelligence, introducing semantic intelligence, and how is it proving as next step to artificial intelligence. So this talk will cover, as I just said, introducing semantic intelligence, and I will bring forward some ontologies that our group has developed, a snippet from the linked data tutorial that was presented on the very first day as the pre-conference tutorial at ISIC 2022. And after that, I will like to take the audience to the progress that is being done in a project, that is the legal information project our team is going on. And then we will discuss about the next steps. We are proceeding further with all the projects that we are doing in. Starting with introducing semantic intelligence, as you could see, the timeline is there. Starting from the pre-90th century BC, use of fire, wheel, language, then development of civilization, and so on. If we come to the very last slot, you could see 2016 to 2050. 2020, it was the fourth industrial revolution. And 2020 to 2050, we can say artificial general intelligence. It is 2022 right now. Artificial narrow intelligence started in 2016. What is narrow intelligence, general intelligence, and super intelligence? What we do today is supposedly narrow intelligence, because what researchers are generally doing is they are doing machine translations with reinforcement learning, maybe deep learning, maybe. Otherwise, what was there before 1980s, it was artificial intelligence, list-based systems, or we can say logic-based systems. But every system good in itself, every system good in a narrow domain, but not generally doing good to everything. That is why we are calling it artificial narrow intelligence. They are good at what they are doing, but they cannot do some other tasks what they are not specialized at. So we look forward to artificial general intelligence, and the revolution has already started. How has it started is, as if the audience have gone through the tutorial also, one of the tutorial was from Manas Gaur, University of South Carolina, and Kaushik Roy. They introduced knowledge infused learning. Their lab is working extensively for knowledge infused learning. So they want to mix the two things, that is the machine translation and the symbolic approaches. With this, I will also say that we will be able to achieve artificial general intelligence, and interpretability will come in, explainability will come in, if we are able to achieve artificial general intelligence. And to go forward, it will be artificial super intelligence that is very, very near to human beings. As I just mentioned regarding artificial general intelligence, we want to do the hybrid of the symbolic and the statistical approaches. With the same thing, I have brought here an image. You could see initially, before the machine learning took forward, there were rule-based systems. We used to call them expert systems in artificial intelligence. For example, mycin, dendral were there. We read them in books. So what these systems used to do, they take the raw data and the rules written by the experts. In any particular domain, they are specialized, and they give answers and data, but based upon the rules that are fed by the experts. Then learning systems came there. In learning systems, exactly what machine learning is doing today, raw data is being fed and some training data is also being fed. The answers are also fed along with it. And then they are generating the models. The rules are being generated as the outcome, and predictions or monitoring or recommendations are being done. What we wish for getting AGI is we want to do a hybrid of the rule-based systems and the learning systems, and we are calling it contextual system. That is raw data. Yes, the training data and the answers will be fed to the system, but some background knowledge, some metadata, some knowledge graph is also to be fed to the system so that predictions are done, we get the answers, we get the models. Those models, there is feedback loop also, but in addition, we get the explanations also, and it is not a black box as in the learning systems. So we are able to even explain the predictions that the system is doing. Even the model interpretability comes in if we are utilizing the contextual systems, that is we are doing the hybrid of rule-based systems and the learning systems. How do we achieve this? We very well talk about data. Data to information we talk about, but the focus should be on knowledge that is gained using experience. Even a novice, a child that is born, data is daily fed into the child. With context, he can get the information, but with his experience only as he grows, he accumulates knowledge in its mind. In the same manner, in machines also, if we use the accumulated knowledge, then slowly and slowly with the shared understanding and that intelligence, with the judgment can come in, the action can come in, and we can say that the wisdom is achieved. So I will not go into detail of this DIKW pyramid. Yes, with this little example, we can have a better look of data, information, knowledge, and wisdom. As you could see on the bottom, Tweety, Chichi, bird, wings, fly. These are entities. These are the data that is fed. But if there are no relations, then we say it doesn't carry any meaning. That these relations will add meaning to the data. If I say Tweety has wings, then it is information for anybody who listens to it, not only data. When it becomes knowledge, when this information becomes knowledge, if we if we represent it in the form of rules and we are able to deduce something, we say if wings, then we call it a bird. If it is a bird, then we can say that it flies. So this is the knowledge. And when this knowledge is applied, it is brought into action, some judgment is taken, we say that there is wisdom. What we say, Tweety has wings, so Tweety is a bird. And when Tweety is a bird, so Tweety can fly. So we are applying this knowledge, the action is being taken, and we say that the wisdom is achieved. From as I'm talking about a leap from information to knowledge, so here is a very good example from Society 5.0. You could see on the left hand side conventional knowledge production process, and on the right hand side you could see the knowledge production process in Society 5.0. In this conventional knowledge production process, you could see physical space and cyberspace as the separate things. The phenomena, people, social interaction is there, and with this phenomena, data is generated which goes to the cyberspace. Then you could see there are humans in between, and these human beings are deciphering the data to render meaningful information. This information is again deciphered by humans to derive some laws, to generate some action, and we say the knowledge is there. This knowledge is further used to make improvements and back to the physical space. Or a feedback loop can also be there to adjust the decision-making criteria. This is the conventional knowledge production process. But if we talk about Society 5.0, then you could see there is a convergence. Humans are not there, and we want to do the same thing what humans were doing here using artificial intelligence techniques. So there is a complete convergence of cyberspace and the physical space. This Society 5.0, as you could see, it goes beyond the optimization of individual fields to the optimization of society as a whole. How? By taking a leap from information to knowledge. So you could see very well, again, the data is generated into the cyberspace. It is automated sensing of big data. The data is accumulated We analyze the past performance, that is learning is there, and we say that the information is achieved. You analyze the information, we say we get the knowledge, and the feedback loop can always be there to adjust the decision making criteria, and the final output adds value to the physical space. It adds new value, it instructs the new operators and so on. So this is what is today's society. We are looking forward to society 5.0. We all, if we talk about the semantic web vision, because I'm talking of semantic AI, I'm talking of semantic intelligence, how it comes in, I want to talk about the motivation of the same. This is all what I just discussed. We want to achieve it, but how to achieve it and from where the motivation has come. This is the semantic web vision. Previously, before the semantic web came in, there was a traditional web, as we talk about web 1.0, web 2.0. It is the web of documents. You could see, as you even search the web, you get the results as documents. There is a long list of results, and you click them, you get the documents. So there are hyperlinks between the documents. From one document, you go to another document and so on. What is the semantic web vision? We are converting the web of documents to the web of data model. It is a web of human and machine readable content. And how we are doing it? By employing linked data. So this is the semantic web. You could see a big circle in the middle, and you could see the blue and red arrows. What they're speaking about, they're speaking about the data sets which are in the big circle, and with every data set, there is data associated. We are not talking about the documents. We are talking about the data that is inside the documents, and every data, say it be a person, a thing, an abstract entity, or a physical entity, every data is identified by an identifier, an IRI or a URI, we call it. So we are talking of data. We have a web of data. We have a web of human and machine readable content. How we are getting it? By employing the linked data. We'll come to what is linked data. So the crux of the thing is, for this slide, that we want to achieve semantic web, and it is possible because of the linked data. Let us come to what is linked data. And before that, just have a look at the timeline also. We started with web 1.0. There was very less social connectivity. As we go to the right, social connectivity is increasing. As we go up, the information connectivity is increasing, also the semantics. So we started with web 1.0. Then we move towards web 2.0, web 3.0, and finally we go diagonally. This is the social semantic web. The social connectivity is also the best, and the semantics is also the best to connect the intelligence. When we talk of semantic web, we say our focus is on knowledge. I was talking about the linked data. Here I have mentioned linked open data. So what is the difference? Linked data, as I just mentioned, we are linking the data. The data is in a readable content, machine readable also and machine processable also, because every data, abstract or physical, is mentioned in the form of IRIs. So this is data, but open data is also there. When we say that data and information beyond just governmental institutions, and also including those from other relevant stakeholder groups such as business or industry, citizens, NPOs, NGOs, science, education, and whatnot, we call it open data. The data is available on the web. It is open data. The various very important institutions which are producing open data include World Bank, the United Nations, the Open Knowledge Foundation, and here at the datacatalogs.org, you will find a long list of the open data projects that are available and the various open data formats that are available. Open government data is a subset of total open data, then big data, and then all the data that is even not open. And here somewhere falls my data. Linked open data will provide data as a service. How you could see a very beautiful picture here. This is from the TED Talk at 2009. You could see this is Facebook, this is myspace.com, Flickr, LinkedIn. Everybody has its own space. Everybody has its closed island, I should say. And they could not provide data as a service. What we want linked open data. They want to connect to other data, but how to do that? Because all of them have their closed islands. Linked open data will be providing data as a service. We will get data integration. The network effect will be there. We will be able to have better navigation, better data management, better data quality, data as a service, as I just mentioned, compatible with the standards, ease of model updates, and also the cost reduction. This linked open data will be making the open government data fully beneficial. How? By providing interoperability to it and standards to it. Data and information will be put into a context that creates new knowledge and enables powerful services and applications. Linked open data will be facilitating innovation and information management and integration. You could see this is the linked open data on the web in 2007. In all, we had 25 data sets. In 2008, it grown to 45 data sets. You could see the growth. 2009, 95 data sets were there. 2010, 203 data sets were there. 2017, 1163 data sets were there. 2020, 1255 data sets were there. 2021, that is last year, there were 1301 data sets. So you could go to linkedopendata.org and you could check out the latest number of data sets, the latest data that is available there. Else, if when linked open data was not there, and today also, as I just mentioned, rule-based systems and learning systems, in fact, the researchers have divided them into categories. Most of them are working with machine translation and very few are working with the semantic web standards, that is the symbolic approaches or a hybrid of both the approaches. So the machine translation systems are working with the Kaggle data sets, with non-proprietary formats even, while this linked open data will be providing you the data sets which are interoperable and following the web standards. As an example or an application to appreciate, we could see the linkage between the semantic web and the linked open data. This example is for Tim Berners-Lee. When you search on Google for Tim Berners-Lee, may I interact with my audience and may I ask, I hope everybody knows who is Tim Berners-Lee.
Yes.
Yes. I don't know how to get hold of the chat right now. Valentina says yes. I hope most of the people in the meet right now are from the semantic web community, is it? Okay, so people know who is Tim Berners-Lee. Yes, Dr. Valentina, could you speak out?
Yes, we know.
Yes, so I think that this second sentence is quite okay for him. So, inventor of the World Wide Web and one of the Time magazine's 100 most important people of the 20th century. So it's
yes, it is already mentioned here. He is the inventor of the World Wide Web and a major role player for the semantic web. So we were talking about the connection between the semantic web and the linked open data. As you could see here, if linked open data is not there, if semantic web is not there, and you search for Tim Berners-Lee or any other thing on Google, we get results in this manner. Then what we need to do is we need to click on links one by one and we need to look inside the documents, peep inside the documents and get the results what we want. But in today's date, if you search for say anything, then you get more information than previously we used to get. For example, you could see as an example here, we searched for places to visit in Kurukshetra, and these were the results we get. So it is not only the documents we are getting. You could see here top sites in Kurukshetra is there. Then on the right hand side, I could see a panel. So what is this all? You could see this is top sites in Kurukshetra. This is recognition of user intent. So the user intent is being recognized by the system. You could see there is an info box on the right. This is the knowledge panel, having directed knowledge of what we intend to ask. Similarly, there are certain recommendations also that you can plan a trip. The nearby hotels, the neighborhoods are mentioned. Then you can see exploration suggestions are also there. The nearby colleges and universities. So this is what is achievable because of semantic web and linked open data. Going back to the same example, Tim Berners-Lee. When we search for Tim Berners-Lee in today's date, we have this knowledge panel on the right hand side. And you could see in this knowledge panel, there is this Turing Award. You click on the Turing Award and you directly reach to the information pertaining to what is a Turing Award. Similarly, you could see the education of Tim Berners-Lee is from the Queen's College. Now the curiosity starts. What is Queen's College? You do not need to search again. And you get the information by clicking on the Queen's College. And mind it is not hyperlinks. They are not hyperlinks. It is web of data. Means a complete information of the Queen's College is in the form of, you could say, one ticket is there. For every information of knowledge, there is a ticket. And that particular ticket comes forward as soon as you click on any of these links. So these are not hyperlinks. So the Queen's College information comes in. Then you could see the reward for a Turing Award is $1 million. Then you could see from the Queen's College, it is located in the University of Oxford. You could get the information of University of Oxford and so on. So a complete graph is being constructed. A complete knowledge graph is being constructed, what we call it in today's date. So this knowledge graph is a graph of instances of data. With this, I have completed the introduction. If the audience wants to ask me something regarding the introduction, we could make it interactive. Else we could do it at the end of the talk even. I'll be happy to take if there are any questions. Otherwise, I'll move forward in any case. Okay, so moving forward with this.
Yes, you can, I think.
Yes, moving forward with this, I have brought forward here some ontologies that our group has developed, and they are still in their infancy. Before explaining what is the developed ontologies, let me brief about what is an ontology, what the term ontology speaks about. You could see T box and A box. These are the terminology that are generally used. What is T box and what is A box? The audience here is very well aware of RDBMS, that is Relational Database Management System. In that RDBMS, we have a schema and we have data. Schema is the header of the tables, the column headers we could say. And then the rows of the table, rows of every table correspond to the data. And here in this our semantic web world, we call the schema as the T box and we call the data as the A box. For example, you could see here a beautiful image, a beautiful diagram. You could see even the legends are mentioned here. This arrow is depicting subclass of, and this is class. This color is referring to class, And this is the particular corresponding resource from this class is taken before the colon. So this class is being inherited by these 4 classes and so on. So protein is a subclass of resource, pathway is a subclass of resource, and there is a relationship, RDF property blue color, there is a relationship between the two, protein and pathway, that is this class is a pathway for this class. So this is the T box. As you could see, number A, this is the T box, this B is the A box. A box means the instances, as I just mentioned, the rows in an RDBMS table. You could see KEG instance and other instance. This color is referring to instance and this color is referring to any instance which is other than from the KEG IRI. So this instance is of protein, this instance is of pathway, this instance is of drug, and so on. So basically I wanted to demonstrate the difference between a T box and a A box. Going forward, this is one of the snapshots from the tutorial only of the Olympics knowledge graph, that is the OlyGraph that we had on the very first day of the conference, the Olympics knowledge graph. This is the conceptual design of the Olympics knowledge graph, and you could refer to the complete video we will pass on to the participants. We demonstrated there the full project of OlyGraph. This is the conceptual design, and these blue things you could see, these are the classes and rest are the literals, and they are connected by whatever properties are mentioned on the arrow. So for every instance we have, every instance is associated with a game, an athlete, a sport, and may or may not be a medal. Similarly, have a look on COVIDO, that is the coronavirus disease ontology. Our group is working on it. What is COVIDO? It is a comprehensive ontology for COVID-19. It is covering multiple dimensions in the domain of COVID-19. COVIDO supports all possible aspects of coronavirus disease knowledge and data standardization, integration, sharing, and analysis. The dimensions I am mentioning have been listed here. The 7 dimensions we have covered in COVIDO include the information of cases, the patient information, disease, symptom, and treatment information, resources, impact on the different business verticals, the related event and decision, and also it may have impact on the various research domains. For example, COVID-19 news, COVID-19 research, these are the core classes of this particular dimension, and certain competency questions have been listed to determine the scope of every dimension. Here is the public permanent ID for COVIDO. You could see these are the namespaces that have been used in COVIDO. These are the classes, the object properties, and the data properties. And some named individuals have also been added to COVIDO. Here is the WebViol version, and so on. So you people could explore it further. I go back to my slides. I hope, I do not know whether another tab was visible to the audience or not, was it? Was the COVIDO permanent ID was visible to the audience?
Yes, ma'am, it is visible.
Yes.
Okay, thank you. So moving forward, after COVIDO, I bring forward feature onto. It is being developed to analyze social media posts for analyzing depressive patients for depression detection and monitoring. What we have done is the features of social media posts have been, which are manipulated by machine learning and deep learning techniques, they have been arranged in a taxonomy. This way, structured data will also help in the interpretation of output that is produced by the various learning models. Feature onto is publicly available at this link. You could explore it later on. In feature onto, these are the major entities in the first column. And in third column, you could see the different schema that we have selected, and we have inherited the IRIs from these schema for these particular entities. For example, for emotion, dominance, we have taken from APA-ONTO. Similarly, for arousal, positive valence and negative valence, we have taken from MFO-EM. We had 3 different available schemas to choose from, and we have chosen MFO-EM for these particular classes of emotion. This is a complete, not complete, a partial list of entities and namespaces that have been considered for the feature onto. Moving forward, the next is Nyon. It is a Nyaya ontology. The Nyaya ontology for the legal information management project that is going on since last 6 months, and we have to move forward for 2.5 more years with it. With this project, we have started by developing Nyon, that is the Nyaya ontology. It is a multilingual modular legal ontology for representing court judgments. As I said, multilingual and modular. Multilingual because we have chosen these 5 languages to start with: English, German, Spanish, French, and Hindi. Right now, we have these 5 modules, that is people, documents, court decision, litigation, and court. Nyon has been published with this permanent ID. Then we have cultural knowledge graph. This is a part of one of the projects that we are going on. Cultural knowledge graph is being developed to incorporate cultural dimensions and properties that can support the development of culturally aware information systems, making use of culturally aware dimensions, different dimensions, and taking culturally aware decisions. This cultural knowledge graph can be found at this link. You could explore it. The various dimensions that have been covered for the cultural knowledge graph, a partial list has been provided here, and a partial list of properties have been provided here. Power distance, indulgence versus restraint, long versus short-term orientation, and so on. Masculinity versus femininity, because all these parameters pave a long way when we need to consider the culture of a particular locale. Here is a screenshot of the architecture that we have utilized for the Olympics project. As I was mentioning, the OlyGraph application, the Olympics application, the OlyGraph, we call OlyGraph as the knowledge graph, including the T box as well as the A box. Starting from data acquisition, we took the data from Kaggle and the Olympic site, created classes, object properties, data properties, and we came up with an Olympics ontology. Using the tools, we developed this ontology in Protege. Using Python, we have done the data extraction. So metadata formation, after metadata formation, that is the T-box formation, creation of ontology, we moved forward to the data storage and management. The data was available at Kaggle in CSV format. So the header was taken for creating the ontology, and the data, the rows, has been taken to create the RDF dump, and the linked open data was created. We have put this data into Apache Gina triple store, and a Sparkle endpoint was created for data access. Some APIs were also created for direct access, and for developers, a Sparkle endpoint was created. Then various use cases were developed: athlete use case, sports use case, country use case, and so on, that we already demonstrated. And here is the tech stack. Here are the different layers for this particular Olympics architecture. Moving forward, this is the legal information management project. We call it Kanun Sarathi. The aim of this project is to offer a platform for legal data curation, management, and sharing as a legal professional assistant tool. This knowledge management platform will facilitate the interpretability, the explainability of decision making, and the reasoning procedures applied. We are moving forward with the 3 objectives. At the bottommost layer, we have to provide the cognitive data governance, that is creation of an Indian legal knowledge base of legal data and metadata as a central repository that will be uploaded on the linked open data cloud so that it can be openly accessible by the developers and also the end users. Then cognitive services and APIs. The APIs will be developed to offer a generic platform for data collection, curation, search, management, and sharing of the legal information. At the application layer, we will be taking care of developing a few applications. And to start with, we are focusing upon the search engine, question answering, and judgment prediction. Here is a list of existing systems in the legal domain. But again, to mention the same, none of them is focusing on the semantic web and the linked open data principles. That is what the project speaks about. We need to move forward with the linked open data principles and come up with an application that caters to the semantic web vision. As I just mentioned, at the application level, we are to start with, we are focusing upon these 4 use cases. That is the intuitive search engine as the first one, so that the end user is able to perform free text search and search from judge name, search from party name or act name or case number. Then question answering will be provided for the end user so that they'll be able to query the document corpus through a limited question answering framework. The analysis of court judgment can be done maybe by the end user if required, or from the court officials, the lawyers and the judges. The issues, facts, acts, arguments by petitioner, arguments by respondent, reasoning, decision, and so on could be analyzed. Then legal judgment prediction could be done before taking the final decision. Some recommendation could be provided to the judge to develop an intelligent search engine for the legal document information retrieval to intelligently retrieve similar cases. And when the similar cases we are able to retrieve, we'll be able to predict the judgment for any input case. These are the 4 target use cases we have started with. The basic modules and tasks that are there for achieving these use cases include the step 1 will be identification of the subdomains. We have already identified 2 domains, that is the criminal and the civil subdomain. Type of documents, we have identified the court decisions. We will be working on the court judgments, not on the rules, not on the acts or any other type of document. And the sources of the legal domain. As we move forward, we will display you certain data sets that we have discovered for the legal domain, and in addition, we are preparing our own data sets also. After this identification step, there is development of the knowledge repository as a framework for the legal metadata. We already mentioned, we have started working on it, and we have come up with NION, that is the Nyaya ontology. Automatic semantic annotation of legal documents using the legal knowledge framework just developed. We need to annotate the legal judgments, the documents that we have identified are the court decisions. We need to annotate them with the ontology or the metadata repository that we have just developed. We need to classify the legal documents into categories. The categories have been provided by the experts in that joining framework. Building a legal knowledge base of linked data using this semantically annotated and classified document corpus, and also in line with the metadata framework that was developed in step 2. We have to find the semantic similarity between the documents. I have brought some of the slides for all of these tasks to have a raw view of what is going on in the project. Then information retrieval is to be done using the document class classification attributes that have been mentioned already by the experts. Here is a very raw abstract view of the tasks that I just mentioned. The web scraping will be done and we get the data set of Indian Supreme Court judgments. After pre-processing, here is the ontology construction. We use the semi-automatic ontology development methodology to construct Nyon. Some of the parts we did automatically, and I should say most of it we have done manually. Then entity and relation extraction will be done from the unstructured document corpus, and needless to mention, this document corpus of legal court judgments is very messy and need to be cleaned a lot. Entity and relation extraction is a tedious task because of the messy nature of the data set. We need to construct the knowledge graph after the entity and relation extraction, and an annotated legal knowledge base is constructed, which will be used further for various applications. Here is the NER legal data set that we have constructed, and the relation extraction data set is on the way. We are calling it ICDEC, that is the Indian Court Decision Annotated Corpus for Named Entity Recognition. We started with the 50 Indian Supreme Court decision documents, and this data set is guided by Nyon. 16 coarse grained classes we have 41 fine grained classes. In this table, hash speaks about the number of tokens of this particular entity in the data set. So for these 50 Indian Supreme Court decision documents, the court entity occurred 66 times with this percentage out of the total 50 documents. We have divided the classes into 16 coarse grained classes and 41 at the fine grained level. This data set is available in all the three encoding schemes: IOB, IOBES, and BILO. Currently, act, evidence, witness, precedent case, and party type are not annotated and they are in process. When I move to information extraction, to start with, we have done the rule-based information extraction. That is the symbolic approach we have utilized. We are moving forward to the machine translation approaches, and in the third phase, we will like to do the knowledge-infused learning, that is the hybrid of rule-based and the machine translation approaches. So here you could see certain rules we have written for the named entity recognition, and here are the results. For these entity types, as we could see in the data set, for the party entity type, total in these 50 documents, there were 92 in number. The court entity was 66 in number. We could see here court 66, party 92. These are the total entities in the data set. That is the gold standard we created. The identified entities using such rules, 78 for party and 47 for court, and similarly we found the precision, recall, and F measure. Good results, but still there are scope of improvement we could see. Similarly, for relation extraction also, we have written certain rules, and here are the results. Session chairs, I will like to ask, how much time do I have?
Nearly 10 minutes.
Dr. Valentina?
5 minutes.
10 minutes.
Did you say 15?
5.
5 minutes only. Okay, okay. So I will try to speed it up, and I will provide the slides and the full video so that the audience could look into at some later point of time also. I will try to finish the rest of the slides in next 5 minutes. I was discussing about the rule-based information extraction, NER and RE. Here are certain competency questions that we framed initially so that we could test our NER and RE approaches. For example, you could see what are the various sections of IPC cited in crimes against women. Case has crime against women, and those cities have cites, it cites IPC section, which is a IPC section. So this is from T box, and the question marks represent we want to find the answer to it. Here is the scenario, how, or the architecture, I should say, how we are proceeding right now with finding the semantic similarity between two court judgments. We are taking the corpus, data pre-processing is being done, and the clean text is passed to the semantic similarity approaches. We have till now applied the word vector based and the transformer based approaches, and utilize the Pearson cosine with cosine similarity. We have found the similarity between the document pairs, and finally evaluated using the Pearson coefficient. We are also in discussion with an expert from the Punjab and Haryana High Court of India to get the expert similarity score. And we have got two data sets. This is one of the model reference that we are looking at, and this is the another one. This first one has created an Indian data set for the Supreme Court decisions, and the second one has created a data set for the US court decisions. I will come to it. Here it is. This data set one is for the Indian Supreme Court case decisions, and this is the baseline model. These are the authors who have created it. This data set contains 47 gold pairs, and we have utilized this to evaluate the approaches we are using. This data set too comprises of the US Supreme Court decisions, and it has been created from the Wikisource. These are the results we have achieved for the word vector based algorithms. These are the 47 case pairs. You could see in the left hand side 24, then till 47. And here are the cosine similarity score. And then, as I mentioned, for the evaluation, we have used the Pearson correlation coefficient. Not very good values. This correlation coefficient ranges from -1 to 1, and approaching to 1 signifies a good correlation between the two documents. So we could see here that the doc2vec is performing better than the other word vector based approaches. On dataset 2 also we tried fasttext and globe, and these are the results that we achieved. Here I am on the last slide of the presentation for today. I have brought some next steps that we want to work forward. For the legal project, we are expanding the data set for the relation extraction. We want to make the Nyon globalized, because till date it is in 5 different languages, but it is mainly catering to the Indian Supreme Court judgments. So we want to make it globalized so that it is able to cater the different terminology over the globe. NER and RE using knowledge infused learning approaches, document structuring to extract the law points, issues, case grounding, etc. from the case documents. Then semantic similarity based upon these law points and case details we have just mentioned, and utilizing this semantic similarity for the legal judgment prediction. As I mentioned, feature onto, we want to utilize this feature onto for predicting depression number 1, for interpretability number 2, and for explainability number 3. And we are very nearing to our results. for this depression prediction using feature onto. As I mentioned, we developed OVIDO. Now the work is going on to utilize this knowledge graph for various different applications for the benefit of the society. And the cultural knowledge graph we have developed, we want to come up with some application. For example, the major application that is running in our mind says as when one person leaves one country or moves from one country to another, then he should be aware of the various cultural conventions that goes in the new country. He should be aware of those cultural conventions so that he is able to get the culture specific recommendations. So these are the major works that are going on in our group. And thank you very much for being such a patient listener. I am open for the questions you might have.
Thank you, Dr. Sarika, for informative and excellent talk. The audience, attendees, have you any questions to Dr. Sarika?
So maybe I will have one question. I'm not a legal expert, but maybe Dr. Sarika, you have already investigated the domain. So the legal documents, they are classified. For example, these legal documents come from family law. These documents come from another law, economy law, or I don't know. Are there these classifications? Are they standardized already on both level? I mean, or you have in India your own classification of documents?
Yes, thank you, Dr. Valentina, for this question. A very important question because, as I mentioned in the last slide, that is next steps. Till now, all these document classification actually will be guided by NION. And NION, the version 1 of NION, that is even that version will be presented in the evening session of ISIC only. That version of NION is catering to Indian Supreme Court decisions only. Though it is multilingual in 5 languages, but it is not globalized yet. Our next step, and we have taken a deadline of 4 months for ourselves, our next step is making NION globalized, so that all the court judgments from across the globe, or at least from the 5 major countries that we have listed, we will be able to classify those court judgments also. They will be guided by NION. Till date, we are able to do only for the Indian Supreme Court judgments.
Okay, thank you.
I hope I am able to answer the question. If there are any more, otherwise you people are free to email me, or you could go to our group web page and have more information about what we people are working on. Thank you so much.
Thank you.
Thank you, ma'am. This is Sachin Pawar.
Hello, Sachin.
Yeah, hello. Thanks for the interesting talk. So I'm interested in this legal data sets or resources that you are creating. So are they available publicly, this ontology
Yes.
as well as entity relation?
Yes, all of them are publicly available. We will provide you the video also, so you could have those links. I'll provide the PPT slides also. And I think in coming 2 to 3 or maximum 4 months, these papers will be out for public access also. And all the resources are already mentioned in all these publications.
Okay.
So all of you will have access to all those resources, what we have done till now. And the sky is the limit, because there are so many ideas. And even our group, just to mention it at this platform, our group is looking for some enthusiastic people to work upon this legal project. We do have funds, but we are looking for good, energetic people to work upon the project. You could spread the word, and if we find people, we are open to recruitment immediately.
Okay, yeah.
Yeah.
So we in TCS, we have also worked on this data set for some purpose, like for identifying witness information or evidence information from this data set. So that's why I found this very interesting.
Okay.
So this will be useful for us.
Yes, these are the two data sets that we have just used, and we are in process of creating one more data set, because I could see this data set of 47 pairs is pretty old.
Yes, yeah.
So we want to incorporate the latest court judgments, because I could see the structure of the judgments has changed a lot since then. So we are in process of creating the new data set, and we welcome the collaborations. We welcome